Hello, so welcome to the Excel special training companion to the MOOC course on biostatistics and mathematical biology. First of all, when you open the Microsoft Excel, you will have to enable the data analysis toolpak. So this is how you are doing. First of all, I'm clicking File, then I go to the options. So in this options on the left side, I click here add-ins, then manage Excel add-ins. I click here go, and then analysis toolpak is here. I have to click this analysis toolpak, and then I click OK. So when I click OK in this data sub menu, you will see that the column called analysis that is actually popping up. So this is extremely important for doing a number of statistical analysis in the Excel. Well, this particular tutorial is concerned with the charting in the Excel, so how to generate different kinds of chart. So the first one we will see is this particular the data, and these are nothing but mango tree heights in you can see the 7 different plots. So if I highlight this much, then over here I can see count is 15. So this is totally there are 15 elements in each of these groups. So these are groups A, B, C, D, E, F, G, while in the G there are only, as you can see that if I highlight it, I can see that there is only 10 elements in this the group. So for this, to summarize this data, the best option would be I can go with a bar chart, or I can go with a box and whisker plot as well. So before generating a bar chart, let me tell you how did I put these numbers 82, 86, 90. Did I type all the, of course you can type it. Just click on any cell and you can just type any value 67 or 89 like that. So that is one way out. Another way, very interesting way, is that I can actually I can use a function here. Remember that in Excel every function will go with start with equal to sign, so I have to click equal to, then the function is RAND between, so I can just go to this item to by clicking my downward arrow key. Then I have to click the tab button, then I will have to specify the two values. So let us say I would like to generate a random number between 25 and 75, so 25 meter and 75 meters. So I just have to click the bottom is 25, then I have to put a comma, the top is 75, so I just click here 75. I just have to close the bracket and enter it. So see that it's 39 has come already, so I can simply drag it. So you can see that the difference now in the cursor. Right now it is a plus, while outside is also plus, but when I move this cursor towards the edge, the corner, right side bottom corner, it turns to be a plus sign. So whenever it turns plus sign, I click this and I just drag to all other cells. So you can see that all different random numbers have been generated. I can drag towards my right side as well, see that. So another set of random numbers have been generated. So this is the easiest way to generate these random numbers. So well, I don't need it, I'm just showing you how to generate it. So I just have to clear all these things now. I just have to click the clear arrow here, the clear all, so that will be cleared now. Fine. Now, as I told you, one option is I just have to make a box and whisker plot. So box and whisker is a really nice one for a summarization. So the new Excel do support the box and whisker, so let us generate it. So I just have to click Control A to select the whole table. Then I click here insert. So this is how any kind of chart is being formed. Just click on this insert, and then this is the chart. So I just have to click here the charts. Recommended charts will come, don't worry about the recommended. You have to click here all charts, and on the left side you see different kinds of charts. This is how to generate any kind of chart. I click here box and whisker, so it's just a preview of this chart, and I click here OK. See that this is the box and whisker has already come up. So in this box and whisker you can see that there are actually you can see that on the top is the value 90. This one is your upper quartile, while this one is your lower quartile. This whisker will go, this 90 is actually your maximum value, while this particular value, that is basically 41, is your minimum value, while this rectangular top one is the upper quartile, that is your 75th percentile, while this one is 25th percentile, while the arrow, this this line in the center is actually at the median, and this x is basically your mean. So everything has been plotted. So this is a very convenient way to summarize this data set. So this is called the box and whisker. I just have to click here on the chart title, and I can just type that it's mango tree heights. So this is exactly the way to make a chart in the Excel. So this is our box and whisker plot. Now let us create the bar chart. So how to create a bar chart? So before creating the bar chart, Excel cannot simply create the bar chart. So if I try to make a bar chart from this raw data, it becomes so haphazard. So instead of that, let us first calculate the mean. So mean is nothing but arithmetic mean or average mean we have to calculate. So to calculate the mean, so all I have to do is that the function is called equal to average, average, and I click here tab, and I just have to highlight all these cells. So I click here all these cells, and then I click enter. So this is the mean of the A column. So likewise I can have to calculate all up to G. So I don't have to calculate again and again, I just have to drag it. So remember, the cursor turns to plus sign, and then I just have to drag it. So everything has been calculated very fast. It's very convenient way to calculate by copying the formula into different cells by dragging. So now I have calculated the mean. Now how will I actually add this one? So I just have to click and hold my shift key, and I just have to highlight the first, because this one is the first one is basically the header. So I just have to click and hold my control, not the shift but the control key. First I highlight it, then I click control, and then highlight all the mean as well. So the two things have been highlighted now, A, B, C, D, E, F, G, which are my header, and these mean values have been highlighted. So now I'd have to go to the insert menu, and then I just click here recommended charts, and then this particular chart is just fine. This is nothing but a column graph. So I click OK. So as you can see, the column graph have been plotted here. So what are this column graph means? A, B, C, D, E, F, G are nothing but the groups, and the columns are drawn in the heights are drawn in proportional to the mean. So the first one is 66, then 66.8 and all. Well and fine. I can also change the chart title here. I can just put mango tree heights here. Now let us also put a error bar of this chart. So how will I put the error bar? So error bar could be multiple things that we are going to learn more about this error bar in the 9th module, but one of this common error bar is standard deviation. So I just have to put SD here, standard deviation. So to calculate standard deviation in Excel, the formula used is STDEV. So I click here equal to STDEV. Then there are two options coming, P and S. Well, multiple options are there, don't have to worry, but these two are, P means population while S means sample. So as this one is a sample, I have to calculate sample. So most of the time you will be looking at the sample standard deviation, not the population. So this is a sample standard deviation. Then I click here tab, then I have to highlight all these cells of the A group. So this is the A group standard deviation, and to calculate for the rest of the group, all I have to do is just drag it to the rest of the cells. So these are the standard deviations calculated for all these 7 groups. We now have mean, we now have the standard deviation. Mean has already been plotted, and from in this graph, the mean, the column, we have to add an error bar highlighting the standard deviation. So how do we do that? So what we have to do is that once you click this chart, then the design format will come here. Click on this chart tools design first, then click here the chart element, add chart element. I click here add chart element. Well, multiple options are coming here. One of the option is called error bar. I click here more error bar. Don't go with the standard deviation, because that will calculate the whole group standard deviation, which is not what you want to do that. We have to calculate group wise. So more error bar options I have to click. Then you have to choose more error bar options here. So what kind of the options would you like to go with? This is basically on the right one. You have to click on the error bar options, and here instead of fixed value I have to click custom value. See the value of the error bar, it has to be custom. Then I click here specify value. I click this specify value. Then this box will come up here, custom error bar options, right? The first one is positive error value and second one is negative error value. So I click here positive error value. I don't have to click anything, it's already been clicked, and just highlight all the standard deviations. Now I click here negative error value, this one, not here, but I click here this one, and then highlight again all the standard deviations, and I click enter, and then I click OK. So as you can see here, this chart has now got beautiful error bars in it, and these error bars are the standard deviation error bars. So you can see that standard deviations are different from different thing. So probably E has got the least standard deviation. Let us inspect it here also. So as you can see, the E has got 61, all the rest has got more than that. So this is a very nice way to illustrate the standard deviation error bar in this mango tree data set. Now let us go to the next data, that is sheet. So in Excel these are sheets, something like the tab. So I click the sheet number 2. So sheet number 2 has got year, literacy rate and standard deviation. So literacy rate and year is for India. These are actually the real data, but standard deviation is not the real data, right? Now for this, perhaps the best option for the literacy rate is it's a time series. As you can see that these are time and these are equally placed, right? Each one is spanning 10 years. So probably the best option is line graph or XY plot. So let us highlight literacy rate up to here, and I click here insert recommended charts. I can click here, and then this chart is what I wanted as scatter. So scatter chart is used to compare at least two sets of values or pairs of data. Use it to show the relationship between sets of values. So this is perfect. These are actually XY scatter with these points have been linked with a line. So this is perfectly fine. I click here OK. So as you can see that this chart has already been created. Now let us also put the error bars in it the same way like the earlier. Error bar could be the standard deviation here. All the standard deviation. To input this error bar I have to click here, as I told you, design, add elements, error bars, more error bar options. I click the last option here and I click the custom specify value. I click the positive values will be all these values. So if I put only positive, it will come up like this. So if I have to put my negative values as well, I just have to highlight it, and again I click all these values. I click enter, and then I click OK. So you're going to see that it will have different standard deviations for each of these data points here, positive and minus. As you can see that in 1990 standard deviation is extremely low because it is just 1. Then perhaps at this one, 1970 the standard deviation is very high, or 2000 is extremely high. So as you can see 2001 standard deviation is 15. So that is exactly how to input the error bars in a line graph. Now let us move on to the next sheet here. The sheet number 4 is the raw data of number of key punching errors. Again I have randomly created this data set by equal to ran between 0 and 5. You can also make it and see it. So perhaps the best way to summarize this is by a histogram, right? So you can insert it, recommended charts, and this is perfectly fine. Pareto is kind of a histogram, but it is actually a sorted value, right? It's a sorted histogram, so in descending order. So the highest frequency, then the next highest frequency, and then the lowest frequency. So this is a sorted histogram. I click here OK. So it's a histogram. You can see that 0 to 2.2. So basically it's automatically calculated by the Excel, and there is no way to specify the bin size manually. That is actually a caveat by using the Microsoft Excel. But anyway, you can see that 0 to 2.2, that means 0 to 2, so number of errors is around 13, so the value is 13. Then the next one, the value is 6, so that means that 2.2 to 4.4, that means 4 and 3. So number of errors 3 and 4, there are 6 points. Then 5 and 6, there are only 4 points in it. So this is a sorted histogram. And now you can see that this one is the line indicating orange color. The line indicates the ogive. So ogive is cumulative frequency distribution function. So now you have got an ogive as well as a Pareto. So this is a very nice way to summarize this large and complicated data set. So just by looking this one, I can see that it's actually the most of the errors were 0, 1 and 2. So the typist is quite a good typist, and the shape of this ogive is not a sigmoidal. So I would say that this is not normally distributed, so it's not a Gaussian distribution at all, right? So now let us move on to the next sheet here, sheet number 5. So in this sheet you can see that this is phenotype is round yellow, round green, wrinkled yellow and wrinkled green, and total. As you can see, this is the data from the Mendel's dihybrid cross. So you can see that these are observed frequencies here. As you can see that this table is already a summary table. This is not the raw data, it's already summarized. So round yellow there were 315 seeds, while round green there are 101 seeds. So total number of seeds is 556. So the best way to summarize this will be, let us say there are two ways out. So instead of highlighting the total, I just have to highlight up to. So this is the first one is the header, and all this data I just have to highlight it. Then I have to insert. So one way to summarize is by a pie chart. So we can add a pie, 2D pie. So this will show you how much is the wrinkled green, wrinkled yellow, round green and round yellow in it. So that is one way to summarize the data. So and well, you don't have to highlight this also, the first one. So just have to highlight the 4, and I click here insert, and the pie, 2D pie. So you can see that, so the pie has been now highlighted. So this way you can do this way as well, right? So this is, I'm just deleting it. That is one way to summarize this data. Now if you observe this summary table, there is actually the third column here, that is expected frequency. So in this case, expected frequency is calculated by 9:3:3:1. So that is actually the expected ratio of these phenotypes as per the Gregor-Mendel's theory. So these expected frequency, as you see that the moment I click here, you can see that 556, that is actually the total, multiplied by 3 divided by 16. So out of 16, 9 will be of this, then 3, then 3 and 1. So that is expected frequency. So anyway, this is also a calculated value, while these are actually the observed value. So if the observed value is actually in so how much is the difference between observed and calculated value? So you have to do a chi-square test that we will be explaining it in a later module. So to summarize this data, all I have to do is that I just have to highlight the data here of both the things. Okay, so I can try to insert one of the options. So let us actually go to all different kinds of chart types. So out of the all charts, the one option will be of course the pie, but a special kind of pie is the donut. So I just have to click the donut and click OK. So as you can see, the donut has already been inserted in it. So the difference here is extremely low, so it looks like exactly same, only that this value is a little bit lower, while again the orange is also a little bit lower, but the blue one is exactly same. So anyway, it's very hard to know the differences in the either donut or the pie. So I would prefer to go always with the bar chart. So in this case, so let us click on the recommended charts, and the first one is the clustered column, which looks perfectly fine for me. So I click here OK. So now you can see that these are clustered column. That means that each column will have the two values. So round yellow, as you can see, these are already been highlighted. The legends clearly says it. That means blue is observed frequencies, that is FO, while the orange is expected frequencies or FE. So FO and FE are perfectly in sync, little bit only the minor differences here and there, but otherwise observed and expected is perfectly matching well. And also you can see that here the maximum kind of phenotype is round yellow, while the other two phenotype, the round green as well as the wrinkled yellow, are quite similar, while the least common phenotype is the wrinkled green. So well, these are different kinds of data visualization using the Microsoft Excel. Well, there are different kinds of charts are available, as you can see that in the insert. I click here once again, insert charts, and all chart. As you can see, there are around 15 charts are available: radar, surface, tree map, sunburst, box and whisker, waterfall, combo. All these are different methods available, and I suggest you to give a try in each of these method and get familiarized with the interface of the Microsoft Excel. But remember that if you are very serious in making some visualizations for the sciences, perhaps Microsoft Excel is not the best software to be used. So the best one is GraphPad Prism, in my experience. So we will also cover the GraphPad Prism in one of the next modules. So thank you for watching. Hope you liked it.